everyone, this is the lesson 5.6, the law of sines and cosines. Everything we've learned in chapter 5 so far has all been defined when we have right triangles. The Pythagorean theorem, sine, cosine, and tangent, they all require right triangles. But what we're going to learn in this chapter is how we would find a missing side or angle if we're not given a right angle. So let's take a look. So an oblique triangle is defined as a triangle that's not right. So a non-right triangle we call an oblique triangle. So that means it's an acute or an obtuse. It just doesn't have a right angle. So our law of sines says this formula. When we use it, we're only going to use two of the proportion, like two of the ratios. It doesn't matter if we need A or B or A or C or B and C, A and C, it doesn't matter. Okay, so they're all equivalent, though, those ratios. So this formula is used to find missing sides and angles in oblique triangles when we're given angle side angle or angle angle side. So I know we're used to talking about those when we had two triangles and they were congruent, but this just means that we're going to be given a triangle with this angle, the side in between it, and then that angle, or two angles in a row and then the side. Okay, so we're just given those specific things. It's not talking about congruent triangles. Okay, so if we're given those, that's when we would use the law of sines. The law of cosines is when we're given different things. So I wrote all three versions of the formula down, but we're going to talk about some ways to help you remember that in a second. But this one's used to find sides and angles when we're given three sides or two sides and the angle between them. So if we take a look at the formulas, I know you're like, oh man, I have to remember three new formulas. And you don't really. If you remember the pattern, then you won't have to remember all the letters. So if we looked at that part of it, of that one, it would look like Pythagorean theorem. So we'd have those pieces squared, okay? And then we're minusing 2 times A and B, okay, the ones that are with it. And then that is times the cosine of angle C. Those go on the outside. So if we look at the other ones, B squared is equal to A squared plus C squared minus 2AC, so those are where that comes from, times the cosine of B, because B is on the outside. A squared equals B squared plus C squared minus 2BC from these times the cosine of A. So those outside letters are always going to be the same, and whatever ones are on the inside are timesing those. So when I look at them, I don't even really think of the side letters, I just look at what numbers I haven't used versus what numbers I have. Okay, so let's take a look at our first example. So when we're setting these problems up and we're trying to solve the triangle and find everything in the triangle, the best thing to do would be to start by drawing a triangle and filling in the information that they were given to you. So I always just draw mine as an acute triangle. Sometimes it looks like it's equilateral. I mean, it's not going to be, but it doesn't really matter what you draw yours to look like. As long as it doesn't look like a right triangle, because then you will think that you can use regular sines or cosine. So I just draw some random triangle. I don't even look at how big my angles are going to be. Put an A, B, and C, or whatever letters they're given to you. Usually we use A, B, and C. So then I fill in what we were given. So we were given that angle A is 28. Angle C is 102. So that definitely means my picture's not to scale. And then side C is 25. So that would be across from there, over here on side C. So it's important to remember which ones are sides and which ones are angles. Angles will always have the degree mark, and sides are lowercase. I know with this font it might be hard to tell, but look for the degree mark. And this gives you a unit too. Okay, so now that we have our picture, we can see, do I have side, 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 angle, side? Which one do we have? So then we can determine which formula we have or need to use. So in this formula, or in this picture, we have angle, angle, side. Okay, angle, angle, side. So when we have angle, angle, side, which formula do we use? Sines or cosines? Very good. Angle, angle, side is the law of sines. So we have C, so we're going to use C. Okay, so let's take a look back at our formula. It said the side over the sine of the angle equal to side over the sine of the angle. We can also flip that over and put the angles on top if that's what we're looking for, and then put the sides on bottom. It doesn't matter, as long as you flip both of them and not just one of them. So these are the ones that we have both of, and we need to find the other ones. So it helps if you make a list of what you need to find, and I always do that off to the side. So in this problem, if we're trying to find everything for that triangle, we're missing angle B. We don't know what angle B is. We're missing what side A is. We don't know how big this side is, and side B. So that's my list of what we'll find. Angle B is obviously the easiest thing to find. So for angle B, we just have to do 180 minus the other two. We get that angle B is 130, 50. Okay, so now we only need two things. So 50 degrees is for angle B. Okay, so I'm going to find side A first, since we know that angle. So we know that side A over the sine of angle A is equal to, since we know the C's, I'm going to use that one, C over the sine of angle C. So there's our formula. Now we're going to plug in what we got. So that would be A is what we're looking for. We know angle A is 28. C is 25, and angle C is 102. Oh, by the way, I changed the question numbers. I'm sorry, I forgot to tell you at the beginning. You're probably like, where is she getting all these numbers from? I took off all the decimals, so that way it's easier to do it. I did it for all of them. I just got rid of the decimals and left the other numbers. So you can just scratch out the decimals to make it match mine. We have to do a lot of calculations, so it was just too tedious with the decimals. That's why I got rid of them. Okay, so now if we take a look at this proportion that we have, we need to find A. So since it's a proportion, I would just cross multiply. So we would have A times the sine of 102 equals 25 times the sine of 28. And then how do we get A by itself? Very good. We'll divide by the sine of 102. And so A is equal to 25 times the sine of 28 over the sine of 102. So from here, we just have to type that crazy thing into our calculator. If you have a backwards calculator, be very careful. The top part will still be like how you would do normal, like when we were doing it before. And then after you do that, make sure it comes out, and then you would hit divide 102 sine. But if you don't have a backwards calculator, if you have one like this, I would hit the fraction bar first. 25 times sine of 28. Move on down to the bottom, sine of 102. And we get that A is equal to 11.998999959. So if we're rounding to two decimal places, that 8 is going to bump the 9 to a 10, which bumps that one to a 10, which bumps that to a 2. So A would be 12.00. Since we round to two decimal places, we still have to put those as placeholders. So that would be for A. So we're going to set it up the same for B. So we can leave these the same since that's what we were given. So half of our proportion we already know. Our variable B would be there. So the only thing really changing is this angle. That's going to turn to a B, or what angle B is, which is 50. So B over the sine of 50 equals 25 over the sine of 102. So if we do the same thing we did up there, we would multiply by the sine of 50. So B would equal 25 sine of 50 over the sine of 102. So really from here, all we did is change our angle, because that's really all that's changing, other than we're finding B. So now we would just type that in. If you have one of these calculators that's like mine, you don't have to retype everything. You can just use the arrows to move back and then delete the angle we had there and put in the one we want. So that's exactly what we have, so side B is 19.58. Very good. So that was using the law of sines. So let's go down to the next one on the bottom. This one, again, I took off all the decimal numbers, so don't get confused. So step 1 is to draw a triangle. It doesn't matter what shape it is. Step 2 is to fill in what you're given. So A is 25, B is 42, and C is 59. So what do we have in this picture? Very good. We have side, side, side. So what formulas do we use? Very good, the law of cosines. So let's make our list of the things that we need to find, which are all of our angles. So angle A, angle B, and angle C. So once I have two, then I can just subtract from 180 to get the third one. Okay, so I'm going to start with A. So remember our formula said, we're looking for A, this is on the opposite. So I'll write it down. A squared equals B squared plus C squared. So whatever letter I put here, these two are not it. These are the other two. Minus 2 times the letters that are here times the cosine of whatever letter is out here. Okay. So, like I said, I don't even look at the letters, I just look at what we have. So, we are looking for A first, so I'm going to use the side across from it. 25 equals our other two sides times 2 times those two sides times together times the cosine of A. Okay, so I know that really looks pretty complicated, but if we look, we have just a bunch of numbers. Oops, I forgot my squared. We have a bunch of numbers, and we just have to get this by itself. So how would I get these to the other side? Very good. I would subtract them. They're being added. So if I subtract them to that side, then they'll be away from the cosine of A. So I'm just going to write them still as squared instead of typing them in and finding their numbers because they're a lot bigger than and there's more numbers to write. Okay. So from here, how do I get the cosine of A by itself? Very good. I would divide by all of that. And for that one, if you want to times it out and divide by just the number instead of writing times, 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 you can. If we times it, -2 times 42 times 59 is -4,956. So really what we're dividing by is -4,956. You could have just written it like that, like I did with the squares. Or you could be squaring everything as you go. I do it both ways sometimes depending on what my students like to do best. When I did it before, I squared them all out and wrote them out as like the numbers to show you it that way. But I really like writing it like this because I feel like it's faster and easier. But it's the same thing, so it doesn't really matter. Okay, so we divided, those are gone. So we have 25 squared minus 42 squared minus 59 squared divided by -4956 equals the cosine of A. And really by this point you could have typed those all in and made it one number. I just didn't. Okay, so now we want to get A by itself. Actually, before I do that, I'm going to simplify this into a number. If you square those and subtract, you end up with -4,620 divided by -4,956 equals the cosine of A. So again, I just did 25 squared. Squared, 25 squared minus 42 squared minus 59 squared. Figured out what that was. Okay. So how do I get angle A? Very good. This was from 5.4. We do the inverse. So angle A is equal to the cosine inverse of 4,620 over 4,956. I didn't write the negatives because 2 negatives make a positive. So now we'll just do cosine inverse of that fraction. Oops. 4,956. So angle A is 21.22 degrees. Okay, well, that was a lot. So 21.22 degrees. Okay, so now we're going to set the same thing up, but we'll do angle B next. Okay, so I'm going to set it up, and then I want you to work it out by yourself, and when you come back, I'll give you the answer. So if I'm looking for B, I'm going to put B on that side by itself, then the other two sides go here, so that would be 25 and 59. So it's like your Pythagorean theorem part, minus 2 times whatever we have here, times the cosine of what letter we put over there, which is the one we're looking for, B. Okay, so I want you to go ahead and try to solve for B. Pause the video. When you come back, I will show you my work, so that way if you got stuck, you can see what to do. Okay, welcome back. So here's our problem that we had worked out. I subtracted the squares to the other side, just like we did on this one. And then I divided by that big mess right there. I left it written out. I evaluated all that in my calculator, and I got this decimal, and then I just hit second cosine of that answer. So we end up with B being 37.45 degrees. And then to find C, we just subtract 180 minus those two numbers. 180 minus 22.22 minus 37.45, and we get 121.33. Okay, so that is using the law of cosines when you're finding angles when it's side, side, side. So I'm going to do this bottom one, and then you're going to pause to try to do the one at the top. Okay, so first, draw your triangle, fill in what you know, and see what you have. So when we have side, angle, side, that again is the law of cosines. Okay, so what do we need? We need to know angle B, we need to know angle C, and we need to know side A. So I'm going to look for side A first. So side angle side is law of cosines. So if I'm looking for A, I'm going to put it on the left side of the equal sign, and then I put the other two squared. So 12 squared plus 15 squared minus 2 times them times the cosine of angle A. So that's 42. Remember, those match. The reason, well, we used law of cosines because it was side angle side, but that's because we can make those match to solve and find A. That's why I'm finding this one first. And then once we know that, we can use sines to find angle B, and then subtract them from 180 to find angle C. So this one is a lot easier because our variable is over here, not trapped over here. So now all we have to do is order of operations, take the square root to get rid of that, and then we've got it. Okay, so if I do order of operations, I'm just going to type it in my calculator exactly the way it's shown there. So 12 squared plus 15 squared minus 2 times 12 times 15 times the cosine of 42. So I get 101.47. I'll just write it approximately. But is that A? Good, it's not A. We would have to take the square root to get A by itself. So I'm just going to leave it straight in my calculator. I'm not going to hit clear or anything. So I'm going to square root the answer that we had. So I get that A is 10.07. Okay, good job. So now that we know that A is 10.07, we can use that to find angle B because we have law of sines now. Because we have an angle in the side opposite, and if we're looking for this angle, we have the side opposite. So sine of angle B over side B equals the sine of the ones that we know, angle A over A. So I know on the front it put the angles in the bottom, but remember I said if you flip both of them, you can do that. It's easier if the variable you're looking for is on top. Okay, so I know you're probably thinking cross multiply, but we really don't want to get that with the 10.7 or 10.07 with the sine. So all I would do is times both sides by 12 to get rid of that. So the sine of B is equal to 12 sine of 42 over 10.07. And then we'll do the sine inverse to get what angle B is. So angle B is equal to the sine inverse of 12 sine of 42 over 10.07. So sometimes I type it all in together, other times I do the parentheses, hit equal, and then do the sine inverse. It just depends on how good your calculator is, really, how many operations you can use. So if I'm putting the sine inverse, I type that first, I do my fraction bar, so 12 sine of 42, and then in the bottom we have 10.07. So I'm evaluating all of it in one shot. So I get that angle B is equal to 52.88 degrees. And then to find C, I'm just going to subtract those angles from 180. So 180 minus 52.88 minus 42. So angle C is 85.12 degrees. Okay, so I want you to pause and work out the last example. When you come back, I'll show you the answer. So if you get stuck, just unpause it for a second and check the next step and then repause it to finish, okay? Okay, so for that one, we were given angle, side angle. So that means it is the sine, law of sines. So this time we're looking for angle B, which is kind of what we did down at the bottom. So, oh, JK, I did side A first. Oh, angle B can be just subtracted from 180. Just kidding. Okay, so we're looking for two sides then. So that's like what we did over to the left. So we set it up in our ratio and then it just multiplied by what's in the denominator to get the variable by itself. And we get these two numbers for A and C. So go ahead and finish that if you haven't, and then make sure you write down any questions you have. I know this lesson's kind of complicated, and we'll go over it in class tomorrow. Thank you. Werner out.